Okay, good morning. So, in this session, after learning about how to write or how to analyze a series positive and as well as series negative clipper, so here we have come with some techniques which will be applied to the clipper circuits in order to straight away write down the waveform. It will be very helpful for your competitive exam so that you can easily write the waveform or mathematical expression for a given circuit within a few seconds. So what are the steps actually we need to follow? What are the steps we should follow in order to apply these techniques to write a clipping waveform for a given circuit? So first let us discuss regarding series clipper. Either it may be series positive clipper, or it may be series negative clipper. The technique is applicable for series clippers where the diode is connected in series. The very first step is to what we need to trace the circuit in clockwise direction. Whatever the polarity of the source, forget about it, just trace the circuit in clockwise direction. That is what the first step. And the next step, while tracing, if you get a positive terminal of the diode, it is nothing but a anode. If you get an anode terminal, then the positive waveform will be retained in your output waveform. It means the negative portions will be clipped if you get anode terminal of the diode first while tracing. Okay, then if you get, what about if you get negative terminal of the diode? It means the cathode. If you get a cathode terminal of the diode first while tracing, it means the negative waveform will be retained in the output waveform. It means it is a positive clipper. Clear? So if you get anode first, if you get a positive terminal of the diode first, it means an anode, then the positive waveform will be appeared in the output waveform. It means it is a negative clipper, right? Because you are clipping the negative portion. And here if you get a negative terminal first, you will be retaining the negative waveform in the output waveform. That's why it is a positive clipper, because you are removing a positive one, right? So based on what is the reference to decide which is positive and then which is negative, that is different for different cases. As we already discussed, three different cases. One is an ideal, and another one is practical, and one more is what some reference voltages. So the reference voltage to decide which is positive and then negative waveform. In case of an ideal diode, the reference voltage is 0 volts. It means the portion above that 0 is positive and below that 0 is negative. In case of a practical diode, the cut-in voltage will become the reference. It means the voltage above that V cut-in is positive and the voltage waveform below that V cut-in is negative waveform. In case of bias, the reference voltage VR will become a reference voltage, and this above this VR will become positive and below this VR will become negative. That is nothing but a biased condition. These are the three steps which you supposed to follow, which you should follow in order to write the waveforms directly from the given circuit. Okay, now let me apply this technique for this circuit. I have a circuit here where I have a source, diode, and additional DC source. So it means additional reference and then the resistor. And this is what the input signal which is given as sinusoidal signal, right? So now let me go with the steps. First I need to trace the circuit in the clockwise direction. So let me start tracing the circuit from this point. Yes. Okay, while tracing I will be getting anode first. Anode means I will be getting a positive terminal first. It means the positive waveform will be retained in the output waveform. It means it is a negative clipper. So it means this circuit is what? A negative clipper, right? This is a negative clipper because I will be getting a positive terminal first, therefore it is a negative clipper. Okay, so which will decide the negative? So since I will be having a reference, so while tracing I will be getting a positive terminal of this battery first. It means the reference should be in the positive region. Positive region means it should be above this 0 axis, somewhere here. This is your reference. And what is the magnitude of that? The magnitude of that battery is what? VR. It may be 1 volts, it may be 2 volts, whatever it is. So in general it is a reference voltage, since you are getting positive terminal of the battery first. So that's why the reference should be what? A positive. So I know that it is a negative clipper, so this is the reference. So this reference will decide which is positive and then negative. So the portion above this is positive, the portion below this is negative now for this case, right? Since you will be having a reference voltage in the path where you are measuring the output voltage. Therefore, the waveform you are going to get like this. This is what, when the Vi is less than Vr, so the output waveform will be like this. These are the reference, where the reference touches the sine wave. This is the reference, and the waveform will be like this. That is what here. So the negative portion in the sense below Vr has been clipped off, and this is what your Vm, and this is the output voltage waveform. Clear? So this is how, by following these techniques, you can simply write down the waveform within a few seconds. Clear? Okay, now I have another circuit now, where the reference, where the DC source terminal has been interchanged, where the cathode is connected to negative and then negative terminal of the battery. So here let me follow those steps. Let me trace the circuit from the point S. Okay, and while tracing I will be getting positive terminal first. It means it is a negative clipper, no doubt about it. Okay, so in order to decide which is negative portion, I will be having some reference. So here you will be getting negative terminal of the battery first. It means the reference should appear in the negative region. It means below the zero axis. Okay, and the magnitude of that is Vr. So let it be, this is Vr. Since it is a negative clipper, it means it has to clip the negative portion. It means it should clip this portion, right? So the waveform will be, the output waveform will be like this. Right, this is what your Vr, just you have clipped the negative portion that is below this Vr. So this is how you can simply write the waveforms. Let me apply this circuit for the another technique.